And with our rational functions, the pieces that we were doing, we had, if you notice on that note summary I gave you, I put some of the things on there. A rational function was just when you divided two polynomials. With our domains of those, we were looking at what made the bottom 0, because you know in a fraction the bottom can't be 0, so for our domain x couldn't be those values. The piece that we're picking up today is the next thing on here. We are going to get into graphing these things. And so today our focus will be on the asymptotes of graphs. We did do some where we just looked at a graph and we figured out from the graph by looking at it where the asymptotes would be. But now we're going to go through how can I just look at the equation and know where all my asymptotes will be from that equation. So the first thing on that handout, first little blurb there, is you're finding vertical and horizontal asymptotes. And it seems like a lot of rules, but it'll make sense as we go through. Now this ugly looking thing, this is just our definition of polynomials that we've seen before. You have a polynomial on top and bottom, means you're adding and subtracting powers of x on top and bottom. That's all that's saying. Vertical asymptotes, we kind of touched on before. It's kind of like your domain. Your domain is when you tell me x can't be 3, and that means 3 is your vertical asymptote. So your vertical asymptotes, those are lines, so it's x equals what makes the bottom 0. Okay? The horizontal has rules that go with it. The reason behind these rules, I can give you a couple different justifications. They have to do with the degree of the two polynomials you're dividing. If the one on top has a smaller degree, your horizontal asymptote will be 0. Okay? If you want just a real brief justification for why, think about dividing. You know, if I had, for instance, I'll go with the just real simple one. Let's say I had x plus 1 over x squared plus 3x plus 2. Okay, would we all agree that the degree of the top polynomial is 1, the degree of the bottom polynomial is 2, so the top has a smaller degree. This is talking about when you have things as a fraction, that really means divide. Can you do x divided by x squared and get a nice answer? No. So, in other words, this quotient is 0, you just have a remainder left. So that's the reasoning why if the degree on top is smaller, it's always y equals 0. Because if you were to divide them, you can't actually do any division. It's all just a remainder. If they have the same degree on top and bottom, your horizontal asymptote is found by dividing the leading coefficients. Okay, so let me kind of make up a problem and try to justify that piece to you. If I have the same degree on top and bottom, so let's just say I did x plus 1 over x plus 3. Let's say 2x plus 1 over x plus 3. That means divide. So you do 2x plus 1, x plus 3 on the outside. What is 2x divided by x? 2. And you multiply, so you get 2x plus 6. Change our signs. You guys remember doing this last semester? We did our long division. Those cancel and we get -5. Can you do -5 divided by x? No. So that -5 is just your remainder. So your horizontal asymptote is essentially the quotient with leaving the remainder off. You know, this one, it's just 0 plus your whole remainder. This is 2 plus your -5 over x plus 3. The horizontal asymptote is the quotient piece without the remainder. So if it's the same degree on top and bottom, it's, you just divide your leading coefficients. And they're horizontal, so y equals a number. Any questions so far? Now let's talk about if the degree on top is smaller. So if this were like an x squared over an x, then you will be able to divide it out and you're going to get more than just a plain number, right, for your quotient. So in that case, you actually do not get a horizontal asymptote. So if the degree on top is smaller, there is no horizontal asymptote. So now we're going to kind of switch gears. You have all this on your handout in front of you. We are going to start looking at some problems and talking about asymptotes and domains along with those. We did the domain last week, but I do want to make sure we remember those. So I'm going to give you a couple, just domain practice, and then we'll come back and I'll do the oblique asymptotes. So I'll do that in just a second. Okay, what did we do when we found the domain?
Set the denominator to equal to 0.
Okay. So add your 4 over square root plus and minus. Now, is my domain x equals positive and negative 2? X cannot equal. Okay, we know we could write that as an interval. If it's more than one value, I'd let you just list it. So if I'm looking at the domain here, x can't be positive or negative 2. What are positive and negative 2 going to be on my graph?
The asymptotes.
Those will be our vertical asymptotes at positive and negative 2. Okay? On B, I know x minus 1 cannot equal 0. So x cannot equal 1. How would I like for you to write that? How do I find this one? So if I just started out by factoring, what multiplies to negative 21 and adds to positive 4? So what can x not equal on this one? D.
And on the last one, we do not factor out the top.
You can, so that is a very good point. If I factored the top, how do you factor x squared minus 9? So it will factor into x plus 3, x minus 3. Now what actually happens? Those x minus 3's cancel, so you get x plus 3 over x plus 7. So what this means, we will talk more about this part tomorrow. In terms of your domain, x still can't be negative 7 or positive 3. In terms of the vertical asymptote, you only have one of them, at -7. So if something cancels out, it still can't be a part of your domain, but it won't be a vertical asymptote. It'll be what's called a hole in our graph, just an open circle on the graph. So we will talk more about those tomorrow, but thanks for mentioning that. D. What would I do on this one? Okay. You could factor the bottom. Difference of squares, x squared plus 1, x squared minus 1. Then what? Okay. Can the x squared plus 1 break down? The x squared minus 1 would break into x plus 1, x minus 1. X squared plus 1. If I set that equal to 0, what am I going to get? Plus and minus. You do the square root of a negative, it gives you an I. In terms of our domain, do I have to worry about imaginaries? No. So this one doesn't affect anything. What about the x plus 1? That tells me x can't be -1. And x minus 1 can't equal 0, so x can't be positive 1. So my domain here, x can't be positive or -1. Again, we could write that as interval, I'm just not making you on me. Okay. So that was kind of a little detour back to last week. Let's look at the other type of asymptote. So our rules so far. Vertical asymptotes are x equals what makes the bottom 0. Horizontal, if the degree on top is smaller, what did I say it was? Y equals 0. If they have the same degree, what was the rule? Divide leading coefficients. If the degree on top is bigger, there isn't a horizontal. In that case, we get what's called an oblique asymptote. Now, we don't always have obliques. It's only in the case when the degree is 1 more. So if the degree on top is 1 higher than the bottom, we have an oblique asymptote. Oblique, sometimes they're called slant asymptotes. It's just a line that's not horizontal or vertical. To find these, we have to do the long division. So I showed you the long division to kind of justify the rules for the horizontal. With the oblique, you actually have to do it. There's no way around it. We would have to work it out. So for instance, if I gave you 2x squared plus x plus 3 over x minus 4. What's the vertical asymptote on this? Positive 4. Okay, the degree on top is 2, and the bottom is 1. So the top is 1 bigger, so that means it's oblique. So we will set up a long division. Now, I'm telling you to do long division instead of synthetic, because synthetic only works if your denominator is linear and x to the first, and most times it's not going to be. So we're just going to do our long division here. Okay, so you divide 2x squared divided by x. What does that give you? 2x. Then you multiply. 2x times x is 2x squared. 2x times -4 is -8x. We need to subtract this off, so what we always did was change our signs. 2x squared and -x squared cancel. 1x and 8x is 9x. We'll bring down the plus 3. So then 9x divided by x is 9. Now, from here, everything else we do is just going to give us our remainder. If we multiply our 9, change your signs, you get 39. So it's like 39 over x minus 4. The nice thing about this, you don't have to go that far. Just like with the horizontal, I told you the asymptote is the quotient without the remainder. That's the same thing here. You don't need the remainder. Once you have y equals mx plus b, you've got an x and you have a constant, you're done. So this one, our oblique asymptote is y equals 2x plus 9. Now again, this only happens in the case when the top is 1 bigger, because if it's more than 1 bigger, you're going to have an x squared or an x cubed or something like that when you divide, and so that's not linear. Okay, so for our purposes, if the degree on top were more than 1 bigger, we would just say there's no horizontal, no oblique. Would it be possible to have both a horizontal and an oblique at the same time? Horizontals happen if the degree on top is smaller or if they are the same. Oblique happens if it's 1 bigger. So no, you can't have both. It's either or. Either horizontal or oblique or none. Okay? What we are going to do for the rest of the day today is just practice finding asymptotes from equations. So now we have all of our rules. We've refreshed all of our domains, refreshed some of our stuff from last week. So we're just going to look at equations here. Okay. So let's start out. I recommend factoring if we can. When we get to graphing these things, we have to factor. Right now, at least for finding the vertical asymptotes, you need to factor your denominator if you can. So if I were only worried about that, since we're just finding our asymptotes, how would you factor it? 4x squared minus 1. Difference of squares. So we break it into 2x plus 1. 2x minus 1. So my asymptotes, we have 3 types: vertical, horizontal, and oblique. Vertical is x equals what makes the bottom 0. So if I say 2x plus 1 equals 0, what do we get? So my first vertical asymptote is x equals negative 1/2. You can have more than one vertical asymptote, so I have to look at my second parentheses. What would make 2x minus 1 equal 0? These are lines, so it's x equals. Okay, domain is when we say not equal. Asymptote, it is equal. So I have 2 of them. Horizontal and oblique. I can't have both, so we just have to decide which one it is. We look at the degree to do that. What's the degree on top and the bottom? If it's the same degree, divide the leading coefficients. So 8 divided by 4, so my horizontal is y equals 2, and that means there is no oblique here. Why don't you guys try B? So we can't factor the denominator this time. Vertical asymptote is x equals, what makes the denominator 0? Negative 4. Now we decide horizontal or oblique. We know it won't be both. What's the degree of the top? The bottom? So same degree means it's horizontal. You divide the leading coefficients. This is like a 1x. So 3 divided by 1 is 3. So y equals 3 is our horizontal. There is no oblique. We're going to keep practicing. see. Does my denominator factor? X squared minus 1 factors. Plus 1 doesn't factor nicely. If you set that equals 0, what do we get? I. Plus and minus I. In terms of our vertical asymptotes, we only want real numbers. We're not going to graph an imaginary. So for us, what this means is this one has no vertical asymptote. Okay, let's decide, horizontal or oblique. What's the degree of the top? And the bottom? Okay, so if the top is smaller, it doesn't matter how much smaller. If it's smaller, then what do we have? Y. Yeah. Horizontal y equals 0. And no. D. What do we need to do on this one? We could take an x out of the bottom. We could also factor out the top, but that's not really useful for finding vertical asymptotes, so we don't have to. Then what could you do on the bottom? Box method. So it's a 1x squared, so we can do the shortcut. Multiply to -2 and add to -1. How many vertical asymptotes are we going to have? 3. Okay, what's this x out here at the beginning will give us? X minus 2 will give us x equals 2. And x plus 1 gives us x equals -1. So you just set each of those parentheses to 0. Okay, let's talk horizontal and oblique. What's the degree of the top? If they're added and subtracted, you just take the biggest. When they're multiplied, you add them up. So the degree on top is 4. The bottom is 3. So the top is 1 bigger. That means oblique. So we have no horizontal this time, but we do have an oblique. So we find it by doing long division. So I'm going to put the 3x to the 4th. I'm going to put a 0x cubed just as a placeholder. You can put, a 0x and a 0 on the end if you want. Divided by, and your denominator goes on the outside. Again, if you want to put a plus 0 on that, you can. The nice thing is we don't have to do the full long division. We know an oblique is a line. So it's y equals mx plus b. We just have to get 2 terms here. So you start by dividing the first ones. What's 3x to the 4th divided by x cubed? 3x. Okay, if you need to, if you struggle with that, just write it out. 3x to the 4th divided by x cubed. What happens? I can cancel out x's. So we get 3x. Then you multiply. 3x times x cubed is 3x to the 4th. 3x times -x squared is -3x cubed. 3x times -2x is -6x squared. What do you have to do then? Change your signs. Make those cancel. 0 plus 3 would give us a 3x cubed. -1 plus 6 is a 5x squared. You can bring down your next term if you want. Now we have to do 3x cubed divided by x cubed. and that is all I need. So I don't have to finish. This is the piece. My oblique is y equals 3x plus 3. Yes, when you divide, it's just dividing the first term. So 3x to the fourth over x cubed.
And then when you do your top, that's when you use the whole.
Yep, that's when you multiply. It's been a little while since we've done that. Questions on that one? Got two more. Do you guys want a second to try them before we go over? Take a minute and see how far you can get, and then we'll talk about them. So the first one, in order to find your vertical asymptotes, you need to factor the denominator. So 1x squared, so we can do our shortcut. Multiply to 6 and add to -5 would be a -2 and -3. So vertical asymptote, x equals what makes the bottom 0, what makes x minus 2 0, and what makes x minus 3 0. Now we decide horizontal or oblique. What's the degree on the top? And the bottom? And keep in mind, I don't have to write the term with the highest power first. On all of these I have, but it is possible I might have -8 plus x cubed. So make sure you're picking out the highest term, regardless of the order. So that means there is no horizontal, it's oblique. So we have to do long division. So x cubed minus 8 goes on the inside. If you need to, you can put some zeros. You don't have to, it just helps kind of hold your place. And x squared minus 5x plus 6 goes on the outside. So x cubed divided by x squared. Okay, then you multiply x times x squared is x cubed. X times -5x is -5x squared. X times 6 is 6x. Change our signs. Those drop. So then we have a 5x squared minus 6x minus 8. What's 5x squared divided by x squared? So my oblique is y equals x plus 5.
Wait. How do you get the plus 5 again?
So you change these signs, so it became a 5x squared right here. 0 plus 5x squared is 5x squared. And so then we did 5x squared divided by x squared. Any questions there? This one, I can't necessarily factor the bottom. Vertical asymptote. What makes x to the 5th equal 0? 0. It doesn't matter with multiplicities in terms of an asymptote. It doesn't matter that same thing would show up 5 times. It's just x equals 0 for your vertical. Horizontal or oblique. What's the degree of the top? Bottom? So, can you have a horizontal? No. Can you have an oblique? No. So there is none of either one. Okay. What if I asked you for the domain of that? What would you tell me? Name infinity 0, union 0 to infinity.
Why can't you have
Oblique is only if the top is 1 figure. Anything else? I'm done, but I just want to mention one thing. So the assignment today is going to be in Math Excel. And the first couple questions, it's going to give you an equation and then a list of options and say which of these is a true statement. It sometimes mentions x and y intercepts. We haven't found these with these, but we have done x and y intercepts a ton in the past. What is an x-intercept? Where it crosses the x-axis. How do you find it? When y equals 0. A y-intercept is where you cross the y-axis, so x equals 0. So I would check, like when it gives you the list of options, I would probably focus on the asymptotes first, but if those aren't accurate, then you could always find the intercepts. So you have some time to work right now. It's Math Excel, and please let me know if